Hello, and thank you for your interest in Nanalysis NMR Ready 6T Benchtop Spectrometer. My name is Paul, and I'm a junior chemist here at Nanalysis. Today I will show you how to set up and run carbon experiments on our proton-carbon NMR Ready 6T Pro. This version is similar to our 60E that we have previously discussed, but we can observe more nuclei. For this video, we will look at our most common selling spectrometer, the proton-carbon version. Other configurations are also possible if you're interested. This spectrometer comes preloaded with several experiments, including standard 1D with decoupled on, off, gated, and inverse gated, attached proton test, or APT, distortionless enhanced polarization transfer, known as DEPT, heteronuclear 2D experiments, heteronuclear correlation, HETCOR, heteronuclear single quantum coherence, HSQC, and finally, heteronuclear multiple bond coherence, HMBC. For this video, we'll talk about the considerations needed for running regular 1D carbons and DEPT experiments. Although the NMR Ready 6T Pro has a touchscreen, for the purpose of this video, I'll be using a mouse so you can see what I'm doing. To run a carbon experiment, first we have to take the spectrometer out of standby mode. When I'm out of the lab or out on a coffee run, usually I'll have the spectrometer on standby. This allows the spectrometer to shim regularly so that when I come back into the lab, I can start experiments without prior shimming. Now we take the sample and we put it into the spectrometer. In this case, we are using a 4 molar solution of diethyl phthalate in DMSO. Now we can quickly adjust several parameters on the main screen. For observed nucleus, change to carbon-13, locked nucleus, change to deuterium, solvent, DMSO D6, experiment, 1D, and number of scans, 32. More advanced parameters can be changed in the Settings tab. Here you can change the spectral width, number of points to change the resolution, scan delay, number of scans, and number of dummy scans. After all this is set up, you can see the acquisition time by looking here. Now we simply press go, and the spectrometer will start acquiring data. As a visual cue, the LED ring will turn blue. The spectrometer will display a spectrum after the first scan and refresh after additional scans. When the experiment is finished, you can add more scans if necessary or process the data. Right now, we're going to do an automatic phase and baseline correction. At this point, I will save the data file. The file format for this is a JCAM-DX file, which can be opened up on any processing software, such as MNOVA, ACD Labs, and TopSpin. Now let's see how we can run a DEPT experiment with the NMR spectrometer. Running this experiment is very similar to the 1D carbon we just ran. We will use DEP 4 molar again because we already know the sensitivity and the number of carbon signals we should see in the spectrum. To run a DEPT experiment, the nucleus remains the same. The only thing that we need to change is the experiment from carbon 1D to DEPT. Another thing that we can change is we can reduce the number of scans due to increased sensitivity. After we change the experiment to DEPT, we can go to the Experiments tab in the Settings menu and choose the type of DEPT experiment we want to run. We can choose DEPT 45, DEPT 90, or DEPT 135. In this experiment, we'll be running DEPT 135. The duration of this experiment will be 0.71 minutes. DEPT experiments were originally designed to increase the sensitivity to low abundant nuclei such as carbon-13. But currently, these experiments are used to distinguish between carbon centers. In DEPT 135, CH3 and CH centers will appear with positive intensities, while CH2 centers will appear with negative intensities. In DEPT 45, all protonated carbon resonances will appear with positive intensities. In DEPT 90, only CH systems will appear. In this way, the number of protons attached to a carbon center can be easily deduced. When the experiment is done, we can process the data and save it. Now we can start our next DEPT experiment. Our spectrometer can also run samples neat or with proteose solvents. For this carbon experiment, we will use a neat sample of DEP. The parameters are all the same, except the locked nucleus needs to be changed to proteo, experiment needs to be changed to 1D, and the number of scans need to be increased to 32. As you can see, just after a few scans, we can see the expected signals. If you would like to know more about the experiments that we can perform on our spectrometer, please visit our website or send us an email. We'd be more than happy to help.